Hello everyone, this will be a short tutorial on how I created this simple pixel art water shader in MonoGame. Now, before I begin, just a note that I'm still very much a beginner when it comes to shaders, and what I'll show is something I made over one weekend while learning. I know it's possible to make it better and do optimizations, but that's up to you guys where you take it from here. Let's start with ShaderToy. This is a web tool I found to be perfect for experimentation with shaders. If you want to do quick prototyping of shaders, this is the tool. My idea of creating the water shader was simple, with 4 steps. Start off with a gradient with 4 corners specifying colors, pixelate it so it looks like pixel art, create wave-like effects, and caustics to make it look better. This is the code for the shader. I've commented out all the unnecessary stuff for the first step. At the top I've created a section for variables. These are things we'll pass on later in the code in MonoGame. For now I have the water color named blue color and the sand color. The min height variable specifies the point at which water has the highest depth and where the blue color has full strength. I probably should have named it depth, but it is what it is. The next 4 variables just specify the height, or in this case the depth of the 4 corners. We'll use these to get a specific color for a point in this image. Let's ignore all the commented out stuff. To get a gradient for each UV point on the texture, we have to calculate the color. This is done in this layer 1 gradient function. First we calculate the color value for each corner from the variables. One possible optimization here is to do this only once, as these values won't change if the UV changes, but I've left it here. Now to get the correct color value, we first mix the top and bottom corners with the fraction provided by the y value of the UV vector, and then we mix the result with the x value of the UV vector. What this does in theory is, if we have a UV point here, we get the color values of these 2 points by mixing on the vertical axis, and then we mix on the x-axis to get the color value for this exact point. Going back to ShaderToy, we take the UV and return the value from our function. With this we have a functioning gradient as seen here. In order to pixelate the effect, we want to multiply, round, and then divide the UV with the number, in this case size. We also want to add the size variable to control the pixelization amount. To create wave-like effects, we need noise, and I'll use Perlin noise since it's widely used. I already have functions for it that I found online. Pretty much any kind of noise implementation will do. It doesn't have to be Perlin noise, but you might get different artifacts. Next, I created a function that would blend the Perlin noise and the gradient. First, we need to get the Perlin noise value, and since it's between -1 and 1, we want to get it to the range 0 to 1. Then, to the gradient we previously have, we add the Perlin noise colorized with the gradient. Since I created this to be tiled, I also added offset for the noise depending on the tile location. To create a caustic effect, we just need to sample the caustic texture. To use custom textures with ShaderToy, I use this extension ShaderToy Custom Textures. I also colorize the caustic effect with the gradient color. I didn't stop here as I wanted to add distortion effect to this, so I took Perlin noise again and applied it to the point we're sampling from. Like this, we get a nice distortion effect going on. That's it for the prototype shader. Now we can move this to MonoGame. Now shaders written in ShaderToy are written in GLSL. MonoGame shaders are written in HLSL. So we have to translate our shader to make it work. I've created a blank project for this. Now, before we draw it on screen, we want to create our effect. I've created a new sprite effect for this. Now, I'll just copy the code we have from our ShaderToy and I'll paste it just above our main function here. It's actually very easy to translate this from one to the other. There are some things to be careful about though. So first, all vector 2s, 3s and 4s become floats 2 and 4. Next, mix becomes lerp. Next, fract becomes frac without the t. Next, we have itime, which doesn't exist, and so it becomes a variable we pass. Also, remember to remove all of these initial values from variables as they're not needed. Now I'll just take all the code from the main function from ShaderToy and move it down to the main function from this effect file. Now, since we're no longer in ShaderToy, we take the UV coordinates a bit differently, and that's like this. And finally, we don't assign the value to the variable, but we return the color, so I'll just return this. We're almost done now. One thing we have to be careful about is the mod function, as it doesn't work the same in GLSL and HLSL. So to fix that, I'll just define the mod function in the GLSL way, and it will be used here. One difference that we also have to change is the way we sample textures. Let's first move and rename this to a caustic texture. And let's move it down where we have all our variables. Right? Now let's change this to a caustic texture sampler, as we'll be using this for our caustic texture. Now let's add a blank sampler for the default texture, and it has to go first, otherwise our caustic texture sampler won't be used. Finally, let's change the sampling code in the main function and change it to this. We also have to use the blank texture sampler, otherwise it will be stripped when the shader compiles. Now, with the shader done, I'll use it in the blank MonoGame project. I already have the code ready. Now I'll just go over it and explain everything I did. First, we can define the variables for our effect and textures. You can also change the resolution to what you want. I changed it to this so it's a bit bigger. Inside load content, we can load all of our stuff. Now I set the variables to what they've been in ShaderToy for blue color, sand color, min height, delta time, and the caustic texture. Then I calculate the local corner heights for each tile. This lerp function is just a standard implementation of the lerp functionality. I also set the offset depending on where the tile is located in the grid. And finally, you call apply to the shader and draw our sprite with the correct position and size. Clicking on play will have the shader from the beginning of this video. There we have it. You can also play around with these variables, and for example, if I want to change the color to greenish one, we'll have something like this. You can also optimize the shader and change it to what you need to. I already changed it quite a bit from the time I recorded all of this, so now I use it differently and it looks like this. For example, it now uses a height map for the depth, and I also added a few improvements to the visuals. I'll come back to it in the future for sure, but for now it's at a state I'm satisfied with, so I can focus on other stuff. That's it for this video. If you have any questions or suggestions or anything else, put them in the comments below. Like and subscribe if you'd like to see more. Cheers!